Good afternoon.
Good afternoon.
Okay, so in the last class, we had started with the topic acid, bases, and salts, right?
Yeah.
So we've seen what are acids, right?
Yeah.
So acids are the substances which have sour. Okay, so it has
Yeah.
a sour property. So because of the so it is due to the presence of substances like for example the natural foods like curd. Okay, then your fruits like lemon, oranges, they have natural acids present in that. So because of that, they seem to be showing the acid properties like
Okay.
that is they have the sour like properties like that. Okay, and bases they have bitter property. Okay, so because of their chemical nature. Okay, so because of the type of chemical nature, it is showing that is they are bitter in their taste. Okay, so
Yeah.
because of that they are classified as bases. Then we had seen the type of acids. So in the last class, we had discussed about the organic and mineral acids, right?
Okay. Yeah.
So
Yeah. Yeah. Okay.
based on their sources, okay, based on their sources, they are of two types we have discussed. That is organic acid and
And
inorganic.
mineral acids.
Yes, or mineral acids. Organic acids are what? They are formed naturally. Okay, naturally from the source. That is your plants and animal source. Okay,
Yeah.
so then they are called as organic acids. So in the last class, we have seen the list of the acids also. Okay, which are the different organic acids and their sources also we have seen. Okay,
Yeah.
then what are mineral acids, or they are also called as the synthetic acids or the inorganic acids. What are
Yeah.
inorganic or the mineral acids? Okay, so
It is something that which is not found with the nature.
yes, it is not found with the nature.
Nature.
Okay. So it has you can say that they are man-made. Okay, they might be
Yeah. They are.
man-made or they are discovered from a origin source. Okay. For example, which are the mineral acids like sulfuric acid, hydrochloric acid, nitric acid. Okay, so these are some of the inorganic acids. Then the
Yeah.
second there is so in your syllabus, so there is one more type. Okay, so next classification, it is based on whether they are classified as strong acids and weak acid.
We have
Okay,
it.
now
Yeah.
that is based on the strength. Based on the strength. Now you can say a person whether he is weak or he is strong based on the strength. Okay, so if he is able to fight with another person, then you can say, "Ha, Baba, he is strong."
Yeah.
Now
Strong. Yeah.
if he is not able to, okay, he is only like he cannot defend himself, then he seems to be weak. So based on the strength, so these acids are also further classified as what? They are classified as strong
Strong
acids and
acids.
weak
Weak
acids. Okay,
acids.
so what are strong acids? Strong acids, these are highly corrosive acids. Means what? They are highly harmful.
So
Okay,
yeah.
so I said last time. So some acids, okay, if you should handle them with care. Okay, if you do not handle them with care, by while using, it may burn your skin. Okay, so these are highly corrosive acids. Okay, because of that, it may cause some severe injury. Okay, if you
Yeah.
come in contact with such acids, then they are said to be what? They are said to be strong acids. So they are highly corrosive. So they are very harmful for the skin. Okay, then
Okay.
so which are these acids? Acids like sulfuric acid, hydrochloric acid, nitric acid. Okay, so these are very strong in nature, thus they are classified as strong
Strong
acids. Okay,
acids.
because they are in concentrated form, highly concentrated form. Okay, so because of their highly what as they are highly reactive. Okay, so they are able to react with metals. Okay, so they are having the ability to react with metals. Okay, so because of this, you cannot store. Now how you store your water? Okay, you may store the water in your steel, what you can say, steel utensils, or some of them they store the water in the pots. Okay, in the mud pots. Okay, you can store the water in different utensils, different type of metals. But this what your strong acids, they highly
Yeah.
react with the metal, so you cannot keep this acids in the metal. Instead they have to be kept in what? They have to be kept in glass bottles. Okay, you have to you have to keep, you have to store this acids in the glass
Glass bottle.
bottles. Okay, now so these so this is the first classification, that they are called as strong acids. Now what are
But
weak acids?
like they had taught us like in under strong acids there comes hydrochloric acid.
Huh.
Yeah, right. But HCl they like put it to these serums, moisturizers and all, right? HCl, hydrochloric acid. Like you like one of the serum is made of hydrochloric acid. Some of the
Hyd-
serums.
uh, you just see the percentage. Okay, just see the complete name. Okay, uh, there might be derivatives of chloric acid. You just see the complete name.
No, it was written as HCl, hydrochloric acid.
You will not get exactly hydrochloric acid. You can,
Like yeah, it might be mixed, but
it might be a derivative. Okay, it won't be the concentrated one. It might be a derivative, means from that hydrochloric acid, or not maybe from the acid, maybe from the hydrochloric derivatives. Okay, from that compound they
oh,
might
okay.
have derivated something. Just see, it is
Yeah.
good that always, okay, so whenever you have you take
No,
medicine.
like I had like one of the moisturizers on.
Okay,
Yes.
so it is good that always, so whenever you take anything, suppose when you buy a medicine, okay, it
Yeah.
is good that you have to study what are the contents in that. Same with respect to the cosmetics also, okay. So you can verify what is that, okay, which what is contained in that. You can see in the Colgate also, okay. So in
Yeah.
the detergents also, so there will be some chemical composition. So these are all chemical compositions only. Okay, but they will be in certain concentration. So just check once, one more, and next time you can ask me about that.
Yeah.
Okay. So, so this was the first one. Then second one, weak acids. Now, how do you get this weak acid? Okay, suppose from this concentrated acids only, if I
Yeah.
take 10 ml of this concentrated acid and I add 90 ml of water, okay, and from that concentrated acid, I take 100 ml completely of the strong acid. Now, tell me whose strength will be more? The concentrated acid strength will be more, or the second one where I have taken 10 ml of acid and 90 ml of water.
I
Whose
think the
whose strength will be more? Okay.
the
Uh,
concentrated acid.
yes. So the concentrated one, the strength will be more, because what I have done here, I have diluted the acid. Okay. How I have diluted the acid? By adding water. So what will happen to the strength of that when I add water? The strength will become less. It will become
Yes.
weak. So they are classified as weak acids. Okay. So the acids, they are not strong as the corrosive acid. Acid is present. What I have done, I have taken same 10 ml from the strong acid, but I have diluted it. So if you use this acid, it won't be, it will not burn your some like instead of burning, okay, they are still bit of harmful, but instead of burning the skin, you may get irritation, or you may get small bubbles like, or small spots like, okay, it will not harm, it will not severely burn the skin, but it will form something different in small concentration. Okay, the concentration of that whatever the harm to be produced, it will be less. Okay, so
Yeah.
here also, so weak acids, what I have done, I have taken the 10 ml from the concentrated acid and have diluted the acid. Okay, I
Yeah.
diluted the acid. So once I have diluted the acid, what you will get is the weak acid. So the strength has been reduced. Okay, the strength of the acid has been reduced. So these are
Yeah.
called as weak acids. So based upon the strength, it is classified as concentrated acid and the
Weak
strong acids and the weak
weak
acids.
acids.
Strong acids are what? They are directly the origin source. Means what? 100% pure acid will be there. Okay, it won't be 100%. It will be 98.9%, 19 9% like that. Okay. So that
Yeah.
time, some impurities will be present. So that acid if you use, so here the strength will be more. So because of the strength will be more, it may cause some severe harm to your skin. But when you are taking dilute acid, the dilute acid, what you are going to do in dilute acid, that is a weak acid, you are going to take 10 ml of the same acid, that is a strong acid, and to that I am going to add uh, water. So I am diluting the acid. So those the strength will reduce, and those they are classified as weak acids. Okay. So this
Okay.
was the based on strength, they are classified as strong acid and weak acids.
Weak acids. Yeah.
Okay, so which are the weak acids like citric acid, okay,
Yeah.
oxalic acids, then some are carbonic acid. So these are some of the weak acids. Then
Okay.
next is concentrated acids and the dilute acids. Okay, what do you mean by concentrated acid and dilute acids? So based on the amount of water which is present, okay, based on the amount of water which is present. So in the first case, as I said, in the strong acids, like, okay, the amount of water, there is no amount of water, it is completely the origin source, right? So they
Yeah.
are classified as concentrated acids. When you add water, okay, when you add water, what you are going to do, you're diluting the solution, okay, those they are called as dilute acids. So when you increase the concentration of water, okay, when you increase the concentration of water, then what will happen, this the what is that, the concentration of the acid goes on decreasing, and thus they will be classified as dilute acids. Okay, so this is the third classification. So there are three classifications. First, they are classified as organic and mineral acids. Okay, then the second one is they are classified based on the strength, that is they are classified as strong acids and the weak
Weak
acid.
acids.
And the third one is concentrated acid and the dilute acids. Okay,
Dilute acids.
then we have seen the properties of acids. So we were discussing about the indicators also, right? So what is
Yeah.
the role of indicator? It indicates, okay, whether the given solution is acidic or basic in nature. How it will indicate? By change in color. Okay,
Okay.
so
Yeah.
so there is something called as litmus paper. Okay, there's something called as the litmus paper. So there are two types of litmus paper. One is red litmus paper
And blue litmus paper.
and blue litmus paper. Okay,
Yeah.
and another is blue litmus paper. So red litmus paper, what will happen? Okay,
That means that chemical is dangerous.
yes. Okay, now when I take in case of acids, okay, so they this will take, when you take a blue litmus paper. Suppose this is a blue litmus paper now.
Yeah.
Okay, this is a blue litmus paper. So when I dip this blue litmus paper, okay, so I will dip this blue litmus paper in a acidic solution. Okay, I will take a acidic solution. So what I'll do now, I will take a beaker. Okay, in a beaker, I'll take a solution. Okay, I'll take a solution. So I'll take the solution. So okay, this is a acidic solution. So what I'm going to do now, I'm going to take a blue litmus paper. I'm going to take a blue litmus paper, and I'm going to dip it into the uh, container containing the your acidic solution. Now, the moment you add this blue litmus paper, okay, the moment you add this blue litmus paper into the beaker containing acidic solution, this will turn, so the how much the a strip, okay, this will be in the form of strips. So the how much the part is dipped, okay, dipped in the beaker, that much will turn into red.
Okay.
Okay, this much portion it will turn into red. So what it is
But you
indicating?
can't make red litmus to blue, right?
Red litmus turns blue. Okay, now suppose if I take now, okay, one more thing. So just remember first thing this, that when you take a blue litmus paper, okay, I'm taking a blue litmus paper. What I'm doing, I'm dipping it into an acidic solution. So what will happen the moment you add the blue litmus paper, okay, into the acidic solution, how much portion is dipped, right? That much it turns into red. Okay, now the
Mm.
same what I'm going to do now. Okay, so what is the statement? So what is the first property? As you know, that acids, they are sour in taste, right? Acids are sour in taste. Okay, they are sour
Yeah.
in taste and they are soluble in water. Soluble in water.
Water.
Okay, then second property is that they turn blue litmus red. Okay, they turn blue litmus red. Now, one more thing, what you had asked. So if I take beaker, okay, same thing. What I'll do, I'll take again acidic solution. What I have taken acidic solution. What is your question now? I'll dip red litmus.
Yeah.
Okay, now I'll dip red litmus into the acidic solution. What will happen? What do you think will happen?
Will it become blue?
What you think, it will it become blue or no?
Yeah, yeah. Like
There
if you
won't,
put blue acid to a chemical, it can turn red, but
no,
why?
it won't change. It won't change. Okay, it will remain red only because blue litmus can turn, because it is already acidic, right? So
Yeah,
this, whenever acidic solution is there, that time this will remain red only. It won't turn blue. Then what is the role of indicator? It should indicate, no, if it turns blue, then
yeah,
this turns red. How you will make out that the given solution is acidic, right? If it gives
yeah,
your, if blue turns red, okay, suppose acidic solution is there, okay, and what I'm doing, I'm taking blue litmus and blue is turning red and red is turning blue. Then how will make out whether the solution is acidic or no? At
yeah,
least only one result it should give, right? So
yeah,
whenever a red litmus you have taken and you are dipping it into acidic solution, there won't be any change. Okay, red litmus will remain red only when you have a acidic solution. Okay, and blue litmus will turn red, okay, when you have a acidic solution. So this is the second property. So whenever so this is the role of indicator. So it will indicate whether the given solution is acidic or basic. So whenever you have a acidic solution, it will turn blue litmus red. Okay, it will turn blue litmus red. And you know, next property is acids are corrosive. Okay, acids are corrosive in
frozen.
nature. That is, it is very harmful. It may damage your skin. It may damage your clothes. Okay, and
Like all the acids.
all the acids, as in strong acids or concentrated
Yeah,
acids.
okay.
Okay, not
Yeah,
all acids, strong acids. Okay, concentrated acids. So acids, they are highly corrosive. They can cause some severe injuries, like they may cause burns, okay, on the clothes and your skin. Okay, and they are highly reactive with metal, so they have to be stored in glass. Okay, and when acids, okay, when acids, when it reacts with a metal, okay, when or so acid, when it reacts with a metal,
yeah. It becomes.
so it forms what? It forms a salt. Okay, it you can say, if I take a acid like HCl and if I take metal like zinc, it forms ZnCl2. Okay, it forms ZnCl2
Yeah, yeah,
plus
yeah.
hydrogen gas will be liberated. There will be evolution of gas. There will be liberation of gas. So whenever you have a metals, okay, metals, when they react with acid, they give you that is salt plus hydrogen gases liberated. Okay, and when acids reacts with your carbonates, okay,
Yeah,
what is the reaction? So acid, when it reacts with carbonates,
yeah,
carbonates, okay, it gives you salt plus water plus carbon dioxide. Okay, salt plus water plus carbon dioxide. So suppose HCl plus carbonate, I'll take calcium carbonate. It will give you calcium chloride plus H2O plus CO2. Okay, so this is the second reaction. So whenever the acids, when they react with carbonates,
yeah,
okay, it gives you salt, water, and carbon dioxide gases liberated. So this is
yeah.
the next reaction. One more reaction, you know, acid plus base. What
Yeah.
it gives you?
So,
Yes,
uh,
salt and water.
water.
So this is the another reaction. So if acids like HCl, if it reacts with a base like NaOH, It gives
will
you
give you
NaCl
NaCl plus
water.
H2O.
Yes. Okay. So these are the properties of acids. Okay. So we have covered most of the things in the last class. So now what are the uses of acids? So where all acids are used? Yes, where all acids are used?
Soap,
So
detergent, and like uh, dishwasher,
dishwasher. Hmm. Okay. So
even in Harpic.
yes. Okay. So some acids like you can say nitric acid. Okay, if you take nitric acid, this nitric acid, it is used in manufacturing of your fertilizers. Fertilizers are used for what? Agriculture purpose, right? So there nitric acid is primarily used, okay, for manufacturing the fertilizers like ammonium nitrate. Okay, ammonium nitrate. Then it is used in manufactures of your explosives. Okay, explosives. Okay, so in explosives also nitric acid is used. Then for dyeing, for dyes, okay, for plastics, nitric acid is used. Okay, it is also, nitric acid is also used in purification of gold. So when you want to purify the gold, so that time also nitric acid is used. Then
Yeah.
carbonic acid, where carbonic acid is used? Carbonic acid in your soda bottles, right? To form
Yeah.
aerated drinks, right? To get aerated drinks, that is to fill in the gas, right? Aerated drinks.
Yeah.
What is your carbonic acid is used, right?
Yeah.
Then your acetic acid, right? We have seen this. Acetic acid is used in vinegars, right? In vinegars also acetic acid is used because of this vinegar. Okay, it gives you that smell. Okay, sour taste. Okay, sour taste is given. Then most of the time this acetic acid, it is added in the different food preservatives. Okay, for preservation of the food, so it is used as a food preservative. Then there are different more chemicals also. So hydrochloric acid, it is used in most of the your uh, whatever in home. Okay, in home, whatever you're cleaning, for cleaning
Yeah.
purposes, whatever the you're using as maybe the uh,
Detergent.
detergents. Okay, maybe the different that choline and all. Okay, so in that also what is
Yeah.
present, some amount of this acids are present. Okay,
Present.
harpic and also in that so different acids are present. So these are the different acids. Now in your fruits also acids are present, right? In different
Yeah.
fruits, in citrus fruits, your citric acid is present. Then in your what is that, tamarind tartaric acid is present,
Tartaric acid.
right? In curds, okay, in your milk lactic acid is present. So these are the different acids. Okay, so
Yeah.
this that in so some acids, they are good for our health, some are bad for our health. Now which are good for our health? For example, your citrus acid, right? If you eat fruits like orange, okay, lemon, so they will provide you vitamin C. Okay, it will give you vitamin C. And some this will be sources will be present in the vegetables also. So ascorbic acids. Okay, ascorbic acid is also acid which is present in different fruits and vegetables. Okay, then it helps or to keep our skin, okay, and gums healthy. So the gums, okay, the gums also, it has been kept healthy by this acid. Then in healing the wounds, okay, if you get a wound, so that time also it heals it. Then and in manufacturing of your bones, okay, in maintenance, in the maintenance of the bones and teeth. Okay, so there are certain acids which are good for our health, okay, which are some will cause some harmful effects also on our health. Okay, so this was about the uses of acid. Then we are going to discuss about the bases. Now, bases, what are the bases? What is the properties of bases? They are bitter in taste, right? They are
Yeah.
bitter
Bitter
in
intense.
taste. So these are bitter in taste. Okay. Now these like acids, okay, bases can also be classified as strong bases and weak bases. Strong base and weak base.
Yes.
Okay. Now what is the definition of now strong base?
It's something like where where a lot of strong items. No, 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 no.
Strong acids will be strong bases will be corrosive in nature. Okay, strong bases will be corrosive in nature. Weak bases will be non-corrosive.
So it's
Okay.
almost like the same as
Yes.
uh,
So
strong acids.
yes, so some of the examples of strong bases will be sodium hydroxide, okay, NaOH, then KOH. So these are the strong bases, okay. And weak bases, as you know, they are not corrosive in nature as strong bases, okay. And for example, the weak bases are magnesium hydroxide, then ammonium hydroxide, okay, and copper hydroxide. So these are some of the weak bases. Okay, now what are the properties of bases? Okay, now what is the first property? That is they are bitter in taste. Okay,
Mm.
and they are slippery. Okay, when you touch them, they are like soapy. Okay, they are like soapy. They are very slippery to touch.
Yeah,
Okay, so soapy to touch and slippery to touch. So this is the
actually.
property of base. Then if I take a beaker, okay, if I take a beaker and I take a basic solution, okay, I take a basic solution. Now here I'm going to take a red litmus. I'm going to take a red litmus. Okay, so I've taken what? I've taken a basic solution. I've taken a red litmus. So this is a red litmus paper. So what I'm going to do with this red litmus paper now, I'm going to dip it into the solution containing your basic solution. Okay, base. I'll write it base, not basic. I'll write it as base solution. Okay, base solution is taken. Now I'm going to dip the red litmus. Okay, now what will happen? This red litmus, the moment you add it, okay, the portion which is dipped into the base will get converted into blue color. So it turns it into blue color. So what is the it turns red litmus to blue.
Blue color.
Okay, it turns red litmus to blue. Suppose if your doubt is if I dip blue litmus, okay, if I dip
Yeah,
blue litmus in the base, what will happen?
it turns red.
How it will turn red?
Or will it give you a weak base?
No, how it will turn? It won't change only. What is the role of indicators? This
Oh
is the
yeah, correct, correct.
what is the role of indicators? I said indicators will indicate. Okay,
Yeah,
it will
they'll
indicate
indicate.
whether it is acidic solution or it is base. See, it is
Base.
either true or it is false. Okay, it is not both the conditions. It is either true or it is false. Any one answer. I don't want both the answers. I want any one. So either it will turn red litmus. So I have two options. I have a red litmus paper. I have a blue litmus paper. Any one should give answer. Okay, both can't give, right? Both
Yeah,
will not give you a now two persons cannot stand first in the class, right? Only one person can stand first in the class. So same with respect to here, I have two conditions. I have a red litmus paper, I have a blue litmus paper. So at any one should give you a correct answer. Either red should turn blue or blue should turn red. So here what I have taken red litmus. Now suppose now you know now I have taken a base. Suppose you don't know. Okay, I have taken a beaker. The solution is unknown. Okay, the solution is unknown.
and
Okay, the solution is unknown. What I'll do, I'll dip red litmus. I will dip blue litmus. Okay, I say now the red litmus has turned blue. So what will be the solution?
the solution. Mm,
It will be acid or it will be base.
base. Okay.
It will be
Acid or a base?
what? It will be acid or a base?
Acid.
How it will be acid?
Because it's
It is turning red litmus to blue.
I heard it different. I'm sorry. Yeah.
Okay, if it is converting red litmus into blue, then it will be what? It will be base.
Base. A base.
Okay, and if I dip blue litmus only, sorry, now, so in your base solution, blue litmus will remain blue only. It does not change. Okay, it does not change. It will remain same. Okay,
Yeah.
so now here the conditions are like that. Whenever you have a acid, it turns blue litmus red, and whenever you have a base, it
It
turns
turns red lit.
litmus blue. Okay, so this is the condition. Remember this. It can be a question for you like that. Suppose now I have given you the conditions. You have to remember this. Suppose they ask you that in a beaker, unknown solution is there. Okay, and I have dipped both the papers. Okay, I have dipped both the papers. One is a blue litmus, another is a red litmus. I say that the blue litmus had turned red. So what will be my solution? They have asked you. So what will be my
Yeah.
solution?
Base.
I have written up. Read it.
Okay. Blue litmus to red is acid.
Huh?
Yeah, it's acid.
Are you sure?
Yeah.
So you need to remember these conditions. Okay, remember this condition. Whenever acid is there, it turns blue litmus red. Okay, and whenever a base is there, it converts red litmus blue.
Yeah.
Got it? So this is
Yes.
the condition. They will not ask you like this, which what litmus red acid will convert or like this. They may ask you like this, what solution is there? Okay, I have dipped both the papers, red litmus, blue litmus. Blue is turning red, so
Yeah.
blue is turning red. So what is the solution? It is acid. Okay, like this you have to tell. So this is the second property of the base, that is base is turning your red litmus blue. Okay. Some bases, not all the bases, they can dissolve in water. As acids, all acids dissolve in water, but some of the bases they dissolve in water. Okay. If the bases they are dissolved in water, then they are called as alkali. Okay. So what are the examples of bases? Sodium hydroxide, potassium hydroxides. Okay. So these are some of the examples of alkali. Okay. Like acids, bases are also corrosive in nature and it should be handled with care. Okay, they are should be also handled with care. Now, when bases
Does
they
grape also contain acid?
yes, grape also contain acids.
Okay.
So grape also fruit, right? Fruit grape.
Yeah.
Grape also contains acid.
Is it like the same acid as orange?
It contains tartaric acid. Tartaric
Okay.
acid, the
But
acid which
it's
is
not
there.
sour, right? Like,
Some grapes will be sour in taste, no?
oh, yeah, like green green.
Green. Okay, so they will be sour in taste. So it is due to the tartaric acid. Okay, so it has tartaric acid in it. So
Oh,
where we were. Okay, so so these are the certain properties, that when bases, okay, as acids, they react with a metal, okay, and they form salt and hydrogen gas. So here also your metal reacts with a base, okay, and gives you salt and hydrogen gas is liberated so
given.
what I can take zinc plus NaOH giving you Na2ZnO2 plus H2. So this is called as sodium zincate. This is a salt. It is called as sodium zincate. Okay, so two
NaOH.
NaOH. So this is sodium zincate. So this is a salt. So when metal, when they react with base, it forms salt and hydrogen gases liberated. And when base react with acid, what it forms? Salt and water.
Water.
Okay, we have seen the example. One more example I can give you. NH4OH is a base plus acid like HCl. What salt will you will get?
You'll get NHCl.
NH4
Yeah, NH
Cl plus H
plus OH2O. Okay.
H2. Okay, so this is the reaction. So these were certain properties of your base. Okay, now where we use this basis, where we use this basis. So sodium hydroxide, okay, sodium hydroxide, that is NaOH. So it is a base which is used in making soaps, okay, in soaps, then in making your detergents, okay, and your drain
Yeah.
cleaners. Okay, so wherein you are using NaOH. So it is used in the manufacturing or making of these things. Okay, NaOH is used. Then magnesium hydroxide, MgOH twice. Magnesium hydroxide, it is used as an antacid. Antacid means what? Whenever more gastric problem is there, okay, gastric problem is there, so it is used in it is used as antacids. Antacid means what? It is a tablet to treat your gastric issues. Okay, it is used as a source of, okay, as a source of treating your gastric issue. Okay, so magnesium hydroxide, it is used as antacid to treat your this. So it is called as the milk of magnesia. It is called as milk of
Milk of
magnesia. So
magnesia.
there can be a question, there can be a question, which what is milk of magnesia? So what is the answer?
Antacid.
Magnesium hydroxide. Okay, so
Oh, okay, I understand.
this is, it is used as an antacid. It is used as an antacid.
Antacid. Okay.
See, antacid means what? Whenever in your body the acidity levels are more. Suppose you have you have taken or you have drank almost 1 liter or 2 liters of lemon juice. What will happen? What will happen to you?
You will like you'll
You will,
feel very like your stomach burns.
and your chest and all, it starts burning, right? You get
Yeah.
that burning sensation. So that time what you have to do, you have to take a antacid. Okay, antacid. So this antacid contains what? It contains magnesium
Magnesium.
hydroxide.
Hydroxide.
Okay, so it is called as milk of magnesia. So milk of magnesia is what? It is a and MgOH twice. So you have to know that magnesium hydroxide, it is used as an antacid, okay, which is called as a milk of magnesia.
Magnesium.
Okay,
Yeah, magnesium.
so how the acidity is? So how you get acidity when excess amount of hydrochloric acid is present in, excess amount of hydrochloric acid uh, is produced in stomach,
Yeah.
produced in stomach. Okay, so to treat this, so it causes acidity. So when
Yeah.
excess amount of hydrochloric acid is produced in stomach, so to treat this, we are going to take antacid. Okay, that time we are going to take this antacid. So antacid, what it will do? What will be the reaction? So this antacids, it reacts with the acid. Okay, and it forms salt and water. So it releases your acidity, it releases, it depresses, it suppresses your acidity levels when you take this acid antacid tablets. Okay, so when you
Okay.
take this, so what will happen? The your symptom of this gastric issues, okay, it will relieve. You will get relief from that. Okay, so antacid, when you take antacid, the acid levels in your stomach, okay, it gets suppressed, it gets suppressed. Okay, it gets suppressed, and thus it produces salt and water, so you get a relief from that. Okay, you get a relief from that. Then next is your ammonium hydroxide. So what all we saw? NaOH, then MgOH twice, Then next is ammonium hydroxide. So this ammonium hydroxide, it is used in making fertilizers, okay, in fertilizers and household cleaning agents. So in your household cleaning agent, for example, that choline, okay, your harpic and all. So in that household, then your dish bars and all, what contains magnesium, ammonium hydroxide is present, okay. So in cleaning agent, this is there. Then calcium hydroxide. Okay, calcium hydroxide. So it is commonly called as slaked lime. What is the name? It is called as slaked lime.
Okay.
Slaked
Slate
lime, not snake. Slaked lime. Okay. So remember, milk of magnesia.
is magnesium hydroxide.
Yes. And slaked lime,
It is the milk of calcium hydroxide.
not milk of calcium hydroxide. Okay, it is calcium hydroxide.
Yeah.
Okay. So calcium hydroxide. So here, so calcium hydroxide, it is commonly called as slaked lime. So it is used in making cement. So where calcium hydroxide is used, it is used in making the cements. Then in bleaching powder, right? Bleaching powder, you know where bleaching powder is used during
It's
rainy
used
season.
when the white clothes are.
Yes. Okay. And sometimes the floor, okay, in the rainy season and all, your floors, the back door floors, okay, they get greenish color, right? They get some greenish grass is grown in that, not greenish, you can say. Some molasses like is formed on the ground. So that time to swipe off that or to clean out that floor, that time bleaching powder is used. Okay, it will clean everything. So bleaching powder, it is used mostly during the winters, okay, winters, rainy season, to clean the floors also. Then fungicides. So where again it is used in making the fungicides. Then it is also used in the treatment of waste water. Okay, in the treatment of wastewater. So in the treatment, so to convert the wastewater into to useful water, so calcium hydroxide is also used. Okay. Then our next is potassium hydroxide. So potassium hydroxide is also called as potash. It is also called as what? It is also
Dash.
called as potash. So it is used in alkaline batteries. Okay, it is used in alkaline battery to manufacture fertilizers. So also for manufacturing the fertilizers and soft soaps for body cleansing. Okay, for body cleansing, potassium hydroxide is used. So for your soaps, in your soap, which you use for cleansing your body, so in that, what is present? Potassium hydroxide is present. So these were some of the uses of base. Okay, these were some of the uses of bases. Next is, so we have seen completely about acids. Then we have seen completely about bases. Next is neutral substances. Okay, next is about neutral substances. What do you mean by neutral substances? Either they are not acidic nor they are basic. So there are certain chemical substances which are neither acidic nor they are basic. Then they are said to be what? They are said to be neutral. They are said to be what? Neutral in
Neutral.
nature. So what is the common neutral substance? Common salt. Okay, common salt. Your common salt which you use, okay, so that is a neutral substance. So next is your pH scale. So next we are going to discuss about the pH scale.
Scale. Yeah.
Okay, pH scale. So the strength, okay, the strength of acid or the base, okay, it is measured on a scale. It is measured on a scale. Okay, it is measured on a scale, and this scale is called as the pH scale. It is called as what? It is called as the pH scale.
pH scale.
So the strength of the acid or the base. So the strength of the acid or the
The
base,
base.
okay, it is measured on a scale, and this scale is called as the pH scale. Fine. Now the scale is graded from 0 to 14. The scale graded from
0 to
0 to 14.
14.
Okay. So A solution with pH number 7 is considered as neutral. So if you have a solution whose pH is 7, okay, a solution whose pH is 7, then it is said to be a neutral. Suppose I write it like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the pH whose
Dolly has 14.
14, 1 4.
Yeah.
Okay. So the pH whose a solution whose pH is 7 is called as what? Neutral.
Neutral.
Okay. Then solutions with a pH of less than 7. So less than 7 means this. Okay. So less than 7 and they are considered as acidic. They are considered as what? They are considered as acidic. So less than 7 means what?
We had scale used for.
That only for to find the strength of acid or base. To see the strength of acid or base.
Like, how do you like find?
Same, it is also, see, it is also like a paper. It is also a strip of paper wherein you have a different colors on that. Okay, it is a strips of paper, 1 to 14. It is different paper. If you have a textbook, just open
Yeah.
it. Okay, page number is 73. I think so.
Yeah, it's 70.
Hmm. So see there are different strips of paper. You can see, yes. So you can see that 1 to 14, you can see different colors.
Yeah.
You see. Okay, 1 to 17. So there are different strips with different colors. Okay. So the pH number 7. Okay, the green color. So you can see it is neutral.
Yeah. The
Okay.
seventh one, the green.
So that is neutral and less than 7. Okay, that is 1 to 6.9 maybe. So 1 to 6.9. Okay, till
That's
6.9, it is acidic in nature.
acid.
Then from 7.1 to 14. Okay,
It's
that is
base.
more, it is base or it is called as alkaline. It is
Okay.
called as alkaline.
Alkaline.
Okay. Now you can see the different indicators. So see the first one, 1. See in your textbook, 1. The indicator 1, strip number 1. What it is indicating? Gastric acid. Means what? The acidic level when you have a gastric issue. Okay. So the acidic level that time will be more. So it indicates in the gastric acid. Okay. If it is more, then it will be more acidic. See, means what? 1 means it is more acidic. 6 means less acidic.
Okay.
8 means less basic. And 14 means more basic.
Okay.
It is ulta. Okay. 1 means more acidic. 6 means less acidic.
Less acidic. Yeah.
8 means less
Less base.
less basic, and
And
14
14
means
means
more
more base.
basic, like that. Okay, so it indicates the different levels. So this tells you the strength of acid or the base. So whenever you want to calculate the strength of acid or a base, it should be measured on a scale, and that scale is called as pH scale,
Yes, okay.
which varies from 1 to 14. So what you need to remember, 7 is for neutral substances which are neither acidic nor base, and 1 to 6 is for acids. Okay, and from 8 to 14 they are for bases. Understood? Okay,
Yeah.
remember this much. Don't stress more. So to what? To calculate the strength of an acid or a base, we need to measure it on a scale, and that scale is called as the pH scale, and this is graded from 1 to 14. Okay, the 7 is for neutral, 1 to 6 is for acidic or acids, and 8 to 14 is for base. Okay, this much you remember. Fine. So we have studied about the indicators, right? We have studied about the indicators that suppose we are not able to taste. What did we give a difference between the acid and base? When you have an acid, it will taste sour. When you have a base, it will
It
sour,
is
it
bitter.
bitter. Now, suppose we cannot taste only. We don't have that tasting thing with us. We don't have a tongue now. Okay. Then how we'll classify whether the given substance is acidic or basic? So that time we are going to use a substance, and that substance is called as indicator. So what is the role of indicator? The indicator, it will help us to identify whether the given solution is acidic or basic in nature. Okay. So how it will indicate? It will indicate by change in color, by showing the change in color. Okay. By showing
Yeah.
the change in color, it will indicate whether the given quantity is acidic or basic in
Yes.
nature. Now, a small quantity of indicator, what I will do, I'll take a beaker. Okay, I'll take a beaker. In that, I'm going to take a substance. I'm going to take a substance. Okay, so there are different indicators. I have discussed China rose, turmeric, litmus papers, right? Last class I told you, you have written C. So there are different indicators. So if I add the indicator, this suppose I've taken a red indicator, okay, red litmus paper. So if I take a red litmus paper, happen to this stuff. Okay, suppose I take a red indicator, it's not working. Okay, so suppose I've taken a red indicator, I've dipped it in the solution. Now this solution, it is not turning blue, it is remaining red only. Then what it means? What type of solution it is? Red is remaining red only.
Yes. Okay.
Red is remaining red only.
Oh,
It is acid.
acid. Yeah.
Okay, so it is indicating. How it will indicate? By change in color. Okay,
Color.
by change in color, it will indicate whether the given solution is acidic or basic in
Yes.
nature. So the indicator will does not affect the nature of the substance being tested. Okay, so based upon the indicators are of two types: natural indicators, or the synthetic indicators. Okay, 76. You have indicators. Just see. Yeah, you have in your textbook about indicators.
Yeah, we do. Page number 73.
After indicators, it is directly salts. Directly from 70 to 73, I have got 76 paper textbook.
You didn't get the 75, no?
No, 74 and 75 pages not with me.
I thought it's 10. I'll check.
Okay. Okay, so indicators and the other things we shall discuss in the next class then. This week, anytime else you are free, I shall take one more class for you. When you are free this week again.
Um, this week I'll be. We like our sports day got cancelled, so from today the summer vacation started.
Okay.
Um,
You're going anywhere?
no, I don't know because my mom is kind of planning.
Okay, fine. So let me know if you want an extra class. Okay.
Yeah,
You can tell your parents whenever
on
you're free.
Friday at 3 to 4.
Friday you're free.
I think, yeah.
Okay, just give me a confirmation. Now you tell me when you're free. What time?
For now I'll be free at 3 to 4.
Friday.
Yeah.
Okay, then Friday 3 to 4, I'll make a note, but you please confirm it in the group. Okay, you
Yeah.
just let me know. So I'll complete this chapter. After this chapter, which chapter do you want?
I don't know. I think I'll just see it.
Okay.
Bio, we have bio and in bio we have nutrition in animals, and in chemistry we'll be having respiration in organisms.
That is also bio only.
Oh, I think transportations of substances.
Potentially substances also is bio.
Mhm.
Okay, we'll do next. Okay, so I'll complete this in one more class. Friday, I'll make a note 3 to 4. Okay, please confirm.
Yeah,
Okay, fine then. So I shall end the session here. We'll meet in the next class.
yeah,
And send me about indicators, those two pages. Okay,
yeah.
74 and
75.
75. 75. Okay, fine then. So yes, 77. This is 78 and this is 79. Okay, fine. Okay, then I shall end the session here. We'll meet in the next class. Thank you.
Okay, thank you. Thank you.
Yeah, you can end.
Yeah,
I'm not able to.
yeah.